Okay, Zoom says we're live. For everybody watching, recording, hang out for a second while we do some stuff on our end to share the link in the Telegram channel. Let's see. Okay, I think I got the link there. Yeah, nice. Thank you everybody for coming to the meeting today. I am broadcasting from my boat, trying to keep an eye on my bandwidth usage. So if I have issues or glitch out, let me know. Oh, there you go. Now your speaker's working there. So yeah, just let me know if I glitch out on your end. So welcome everybody. I'm Chris Troutner. This is the Permissionless Software Foundation Technical Steering Committee meeting for March 29th, 2023. Let's go around and do a quick round of introductions. Stoyan, why don't you start?
My name is Stoyan Zhekov, and I'm helping with some of the JavaScript libraries for the foundation. Thank you.
Nice. Go ahead, Aaron Shoemaker.
My name is Aaron Shoemaker. I worked with a lot of the NFT stuff. Currently, I'm taking a break from the NFT stuff, still involved as much as I can in the BCH NFT SLPs things. And I'm working on some graphical databases right now and seeing how that can tie into crypto eventually.
Nice. Go ahead, Aaron Sunman.
Double Aaron. Yeah, Aaron Sunman here. I'm just sort of setting up a new thing, just trying some things, and didn't have time to set it up ahead of time. So anyway, Aaron Sunman here, and I'm excited to be a part of the Permissionless Software Foundation. I'm a big believer in the idea of permissionless innovation anyway, so making something that makes it easy for anyone to come in and create without having to ask for permission every time is massive, and I appreciate the efforts that you all put in so far.
Yeah, well, likewise. Great round of intros. I'm gonna go ahead and share my screen and we'll get into the agenda, which is going to be fairly short today. Hopefully it'll just be a lot of roundtable discussions. So as always, our agendas are filed on GitHub under the Permissionless Software Foundation GitHub group in a repository called TSC for Technical Steering Committee. And this is we file them as GitHub issues. So this is issue 51. And as always, we've got the scope of the meetings. Today, there's no governance updates. I wanted to give a quick demo on the collaborative CoinJoin project I've been working on. So this is the GitHub repository for anybody who wants to check. And actually, so I'm going to do that, and then I want to get into some of the stuff that Aaron Sunman, Cool Cleaner, has been doing. He's been buying some hardware from Bitcoin Creations, who is a sort of a hardware hacker developer in the Bitcoin Cash space. I want to hear about that. And then Stoyan was sharing some information on a platform called Mason, which lets you move stable coins from one blockchain to another. So looking forward to hearing more about that. But let me jump into this CoinJoin demo. I'm pretty excited to share that.
That a little AI art there?
Yeah. I asked Stable Diffusion to give me like two coins melding together, a coin join. So I was really impressed with
that. Looks cool.
The quality of the image. Yeah, it's like first try. That's what I got. And I was like, that's good enough. So this project was funded by the Bitcoin Cash community through a Flipstarter. And I really want to drive home this idea that a coin join. So what a coin join does is it's a special type of transaction that increases the anonymity. Most Bitcoin transactions decrease your anonymity. They leave little bits of information that a government agency or a blockchain analytics company like CipherTrace or I'm drawing a blank on the big company that does the de-anonymizing for the government. Oh well, it doesn't matter. But there are companies like that exist. and they're constantly trying to de-anonymize people, and for the government, they're highly paid. And so most transactions on a blockchain, on any blockchain, but I'm going to focus on Bitcoin blockchains in particular, they slowly decrease your anonymity over time. You start out anonymous, hopefully, and then you provide this sort of trail of information on the blockchain that these companies' analytics data can follow and try and figure out whose government identity is attached to these blockchain addresses. So it's in Bitcoin Cash, it's intended to make Bitcoin like cash, so both fungible and fast and anonymous like cash. And so this is a problem for those goals. So this is why CoinJoin is important. So CoinJoin is a way of creating a transaction, collaborating with other people to create a certain type of transactions where it's mathematically impossible to attribute an output to the inputs. And so it breaks that information linkage between the coins that you had, which are UTXOs, and breaks that informational link. So these new coins are fresh and re-anonymized. And so there's five design elements that go into a CoinJoin wallet. They're here. There's the packaging, so like the actual user interface you use. So maybe that's a desktop app or a web app. There's the backend infrastructure, which is the stuff that actually talks to the blockchain. There's the HD wallet functionality, so that's preventing address reuse. So every time you spend a coin, you get a new address. That comes from the HD wallet. It's very important. That's like first step in protecting your privacy is you have to have that. And then there's the whole peer-to-peer coordination element, which is just getting people's software to talk to one another and coordinate in order to do a CoinJoin. And then there's the actual CoinJoin algorithm. So examples of CoinJoin algorithms would be Wasabi Wallet is a type of CoinJoin algorithm. Cash Shuffle is a type of CoinJoin algorithm. Cash Fusion, the Cash Shuffle and Cash Fusion were two Bitcoin Cash CoinJoin algorithms. So this is a common misconception. People think that those are not CoinJoin, that they're somehow something other than CoinJoin, but they're just flavors of CoinJoin algorithms. So the goal of this project is not to make the most secure CoinJoin algorithm. It's to provide a framework for these 5 design elements so that CoinJoin can be easily integrated into other wallets, particularly JavaScript wallets. This is a JavaScript project. So like Zapit wallet and Paytaka wallet and the Bitcoin.com wallet, these are not, or the web wallet that we use. Those first 3 examples, they're not JavaScript wallets, but they can integrate JavaScript code. They can make REST API calls, and they can sort of, especially with ChatGPT, they could take our JavaScript library, convert it into whatever other language they need for their wallet, and tap into. So that's like one of the. So there's a few goals here. One is break this all into a modular design of these 5 elements so that people can focus on one specific design element, like the desktop client or the CoinJoin algorithm or the peer-to-peer coordination layer. Those can all be dealt with individually, and you don't have to try and tackle all 5 at the same time. So that's the first goal. The second goal is making it easier to integrate CoinJoin into these other wallets. I'll go into that a little bit. What I'm going to focus on today for this demo is there's a few repositories here. These 2 Electron repositories that start with Electron, these are the desktop application. But I'm going to focus today on these 2, the collaborative CoinJoin API, which handles the peer-to-peer communication and coordination, and then the HD CLI wallet, which is a command line wallet for running these tests. So this would simulate one of the other wallets. And one of the cool thing here is the API creates an IPFS node. And so that's how all these peers coordinate, is over IPFS. So because of that, there's no central server. All these peers just sort of listen to one another and figure it out on the fly. There's no leader. There's no central point of failure. There's no coordination server. These APIs, they also do not, all they know is UTXOs. They don't have any private keys or any mnemonics. They can't do any sort of transaction signing on their own. And for this reason, that makes them non-custodial, and it makes it possible for anybody to set up an API server, and then other people's wallets can attach to it, just like we run multiple full nodes or multiple Electrum nodes or cache stacks to provide like public infrastructure. Because they're non-custodial, there's no private information going back and forth. So probably a good time to switch to this flow chart. What I'm going to demo is essentially this flow chart. So on the left this is two peers that are going to coordinate to create a coin join transaction. So on the left is peer 1, and on the right is peer 2, and they're represented as their HD CLI wallets, the command line wallets, and then they each have their own API server that they're talking to. They could be talking to the same API server, but in this example, they're talking to two separate API servers. And so the API servers, they communicate with one another over IPFS, and then they communicate with the wallets over REST API. So think Web 2 is the REST API, and the JSON RPC over IPFS is Web 3. This is how our cache stack infrastructure works too. And so what I'm going to demo today is each of these players, they issue this coin join single command, and that issues a REST API to their local API server, which just sort of kicks off the coin join. It starts looking for other players to do a coin join with. And so in that step, the wallet is simply giving the API server the UTXOs that it wants to add to a coin join. And I should take a step back. So here in the terminal, I've got these last 4 tabs on the left. So these 2 tabs in the middle, this is player 1. So this tab is the wallet, and this tab on the left is the API. And these other 2 tabs on the right, this is the wallet for player 2, and this is the API for player 2. And so I already updated the wallets and prepared these wallets. And these wallets have a series of UTXOs. So here's a UTXO, here's a UTXO, here's a UTXO. So this one has 37,000 Satoshis. This one has 29,000 Satoshis. This one has 46,000 Satoshis. And this is an example of what I call the dust problem. If you use an HD wallet like Electron Cash or this wallet, and you spend some money, every time, like let's say you need to send $1, and the UTXO that you're spending represents $2.50. That means you need to send $1 to wherever you're spending it, and then $1.50 is coming back as change. And eventually you're going to end up with like little tiny amounts of change that have low monetary value and high information content in terms of de-anonymizing them. And this is what's known as the dust problem. And so whereas people who've used Cache Fusion, they're used to just letting it sit there and churn, and they end up with like hundreds of UTXOs. That's a pretty novel approach to this dust problem that I've never seen implemented in anything else. This is really intended to consolidate all your dust safely and anonymously into a single large UTXO. That's really like the use case here, is you want to get rid of your dust that has low monetary value and high information content into a larger UTXO that you can spend that has high value and low information content. So that's essentially what you're trying to do with the coin join. So what I'm going to demo is these 2 players, and then this is the player number 2. They've got a similar wallet with a lot of dust, a lot of small UTXOs in their wallet. They want to combine these so that they can spend them safely and anonymously without joining all that information content together. And that's why it needs to go through a coin join. So what I'm going to demo, it's going to go pretty fast once it gets going. But what we're going to end up with is these wallets are going to have 1 or 2 UTXOs in them when they're done. So let me go ahead and get this started. We'll start that. So I'm starting the API servers on these 2 computers, and I'll let them spin up for a minute. They're gonna join the IPFS network. they're using the IPFS cord library, which we use in our cache stack. And they're going to reach out and find one another. Right now they're inactive, so they might actually find one another without exchanging any information because they're just sort of inactive. The APIs are just sitting there waiting for the command to start the coin join. So I'm going to do that with this coin join single command.
Are they finding each other through startup through the swarm, or do they already have? Are they already in the peer list? And
they are finding each other through the pub sub. So when they start up, they subscribe to a hard-coded coin join channel, and they every 2 minutes they announce themselves. They say, "Hey, here I am. I'm either looking for a coin join or I'm not. And if I'm looking for a coin join, this is the minimum number of players I'm willing to participate in, and the maximum number of Bitcoin Cash that I have available to coin join." And so everybody is announcing that every 2 minutes. So that's how they find one another. So here it's just submitted the UTXOs to the API. So now the API knows the UTXOs and the total amount of Satoshis that this player wants to participate in a coin join with. So they just did that to both of their APIs. And so what we're going to wait for here is the APIs, now they have the information they need. They're going to find one another. They're going to coordinate to create an unsigned coin join transaction. That's what's going by the screen right now. And then one of them this one just decided to, okay, so that failed on that try. Let's try that again. So what happened is it successfully created the transaction and signed it, but when it tried to broadcast it, there was not enough of a fee. And I've kind of been struggling with this lately. So let me try and let's see. So I'm going to just send a little Bitcoin Cash between one and the other just to.
is there a way to set the transaction fee that you want to?
Yeah, this is the one thing that I'm kind of messing with right now is that occasionally I get this error, and so it's because like I'm only using 2 players right now, and so one of them like doesn't have enough money to pay the transaction fees because they're basically putting everything they have into this into the coin join. So I need to adjust it a little bit so that the player with the least amount of Satoshis puts in a little less than everything they have. So have enough left over to pay a transaction fee. I'm also testing these wallets. So these are HD wallets, so they should be able to grow. Like, they can produce billions of addresses. So addresses are cheap, but you have to be able to track them, and you have to be able to track balances in them. And so that's another thing I'm testing. Like this wallet's up to 77, and so it should be tracking the last 100 addresses. So, okay, let's try this again. That one. Okay, so these are going. So when I give it this coin join single command, it's telling it like do one single coin join and then stop. And so it's updates the balance. It's right now it's reaching out to the blockchain, updating its balances, making sure that all the UTXO information is up to date before it starts, and hands that information over to the API. So what I have it doing now is it makes up to 5 API calls. It gets address balances on an array of 20 addresses at a time, and it tracks up to 100 addresses at a time. So that ends up 100 divided by 20 is 5. So here now it's polling the API. It's given the UTXO information to the API, and every 10 seconds it's polling it to say, hey, do you have an unsigned transaction for me to sign? It looks like the other one is about to start doing that too. There we go. So now we're just waiting on these APIs to find one another and exchange. And like you saw before, it happens extremely fast. So what they're doing is they're finding one another. They're like, hey, they're looking at each one's announcement and figuring out like, am I aware of enough players to start a coin join transaction? And one of them will like make that decision. Like I will be the leader. They sort of initiate this collaborative, and it's random every time. But whoever sort of not initiates it becomes the leader or the coordinator. And so they say, hey, I want to start a coin join transaction with you. Give me the UTXOs that you want to include in the coin join and the output address and the change address. And so then it creates a unsigned coin join transaction, passes it back to all the participants. So there we've got a fully signed transaction. There we go. And then it just broadcast it. So if we go to block share, pull that up, and I'm going to get these two wallets working on their balances. Right there.
So do the addresses that participated in the coin join show up on the Block Explorer?
Yes, they're necessarily part of the transaction. That's what I wanted to show here. This is super weird that Blockchair is not finding the transaction. We couldn't find.
But I could essentially have it send to a new wallet with a different address. Like, so if somebody knew my address, I could essentially send it to a new wallet.
Well, yeah, so I didn't get into enough detail with that. Does anybody know another Bitcoin Cash Block Explorer?
Just the one that's running in the other room. Well,
yeah, this is super weird that Blockchair can't find it. I wonder if there's, I mean, if it went out, oh, okay, well, I can pull it up with full stack. Let's see. Blockchain. Get. I want to look at, or no, it's raw transaction. And I want get a raw transaction based on transactions. Okay, here's the transaction. It found it. I'm just scrolling down to the bottom to see if it doesn't have any information about whether it's been mined or not. It'll probably take a minute. So here's an input and an input and an input and an input. It's got all these inputs. It must just be taking time for this transaction to percolate through Blockchair's database. Man, still can't find it.
Yeah, usually
Well,
they're right on it. I know that's a strange thing.
Yeah, well, let me pull up a previous transaction that I sent out, and then you guys can get a feel for what this transaction looks like. Oh, okay, yeah, here's the problem. Block chair's down.
Oh yeah.
Yeah, okay. The problem is block chair. That is very unfortunate. Of course, that's going to happen when I'm doing a demo, but there's approximately 10 inputs here because each wallet had about 5 UTXOs, and I have a command that it'll just generate 5 UTXOs. And there are, on the outputs, there's 1, 2, 3 outputs. And 2 of these outputs are exactly the same size. This is what breaks the informational link.
Jerry just
So if
shared
any,
another one, Chris. in
what's
the
that?
chat. Jerry just shared another.
Oh,
export in the
nice.
Zoom chat.
Oh, okay. Let me see if I can get to that. Thank you, Jerry. Nice. Okay. Let's see if we can pull this transaction up in something that's graphically a little better looking. There we go. So it has 14 inputs
Ah,
and 3 outputs. And there's 2 outputs that are exactly the same size. So even if an analytics company, Chain Analysis, that's the name of the company I was looking for. Chain Analysis, they get paid large sums of money by the US government and other governments in order to de-anonymize addresses. And they just maintain this whole big database of every address they can possibly de-anonymize. So they exist, it's real. And so people who are paranoid about this, like, you have good reason to be. So anyways, if the Chain Analysis company had somehow attached your government ID to one of these inputs, they now no longer can possibly attach it to the output because they're both the same. And now in this simplified example, there's only 2 players, but we're going to work up to more, like 3, 5, 7, 9 players at a time. And so for each player, you'll have an output of the exact same amount and then change going to it. And there should not be any repeated addresses. This is part of the HD wallet functionality, is like every time you spend money, you never reuse an old address. It always goes to a new address. So that's the first step in preserving your privacy. And then the second step is like taking all these small dust UTXOs and consolidating them into a new anonymized large UTXO.
Well, wouldn't you also, like with the HD, you want to spend like branch down because the upper branches create the lower keys, the lower addresses, if I remember right. Everything can be derived from the private key, and therefore it creates everything all the way down.
Yeah, well, actually, let me look into these wallets. So before I do that, though, real quick, I just want to show. So I updated the balance of the wallet. So now player 1, they only have 1 single large anonymized UTXO, and player 2 has the same UTXO plus some change. So if you're not one of them ended up putting in like everything they had, and so that's why they don't have any change. But if we look at and then here I'm tracking the HD index. A little flaky. If I look at the wallet file, you can see every address that this HD wallet has generated. So every time I need a new address, I just increase the index and I get a new address. So it's a pretty simplified way. There's more sophisticated ways to do this with different derivation paths, and there's like a change address and hardened versus non-hardened. I just keep it pretty simple by anytime I need a new address, I just increment this index and I get a new address. And in that way, I'm never reusing an address. So that's how this sort of simplified HD.
Yeah. Oh, Chris froze. Let's give it a second.
Yeah, he's a little frozen right now. Yeah, that is cool. Boy, it's neat to see this happen live because I've always
Yeah.
seen it happen in Electron Cache, but behind the scenes, all of this stuff is it's a lot more complex than the little graphical UI.
Yeah. Oh yeah. Anytime you get down to it, there's a lot that goes into it. And yeah, Chris is back. We can't hear your audio though.
How about now?
Yep.
Oh yeah.
All right. Sorry about that, guys. Where'd I leave off?
And you left off with the HD wallets. You were showing how you increment the index to create a new HD function. And I think if people are more interested in that, mastering Bitcoin Cash actually goes into that more in depth. So you guys, and that's on is that on full stack? No, that's on the PSF. You have a link to that, don't you?
Yeah, it's at fullstack.cash. And then you can go down to the documentation page. And then right here, mastering Bitcoin Cash, which is Stoyan's formatting of those files.
Yeah.
You can click on that to get to it.
If anybody's watching this and they're wondering, like, well, how do the HD wallets work exactly? There's some good write-ups on that, and then you can take it from there and get more detailed if you want to.
Yeah. In Keys, Addresses, and Wallets, Chapter 3, it talks about HD wallets and the relationship between private keys, addresses, and HD wallets. Yeah. So I'll just wrap up the demo here with this flowchart. So this is what we watched is these two players, they got their APIs going. The APIs are communicating with one another over the JSON RPC. One of the players initiates the coin join and sends a request to the other peers that it thinks are a good fit. They respond by submitting the UTXOs that they want to add to the coin join. And then that coordinator, they combine all the UTXOs and output addresses into an unsigned transaction, which is a coin join transaction, and passes it back to all the players. Each player signs their inputs and outputs so that they can't be changed, and then sends the partially signed. So it sends that unsigned transaction back to the wallet software. The wallet software actually does the signing, not the API. Passes that back to the API. The API passes that back to the coordinating API. It then takes all these copies of the partially signed transaction and combines them into a fully signed transaction, and then broadcasts that to the network. And then it's over. And then all the players on the cleanup, they change their IPFS IDs and their Bitcoin Cash IDs so that when they come back in, there's no way to tell like an old player from a new player. And so they completely reset their identity. So there's no way to track a player from one coin join session to another.
Awesome.
Wow. Yeah, that's very impressive to have that kind of background in that, because I mean, I don't know how it's working. We were talking about, you were frozen there for a minute, about how we've not really seen that back end stuff with Electron Cache, right? It's just a GUI. So to see all this stuff on how it works and to have it not have a coordinating server is fantastic.
Thanks. Yeah, that's the goal, is like this. I'm not trying to build the most secure coin join algorithm. Like, if people want like the maximum privacy, they should use Cache Fusion. They should continue to use Cache Fusion. Not trying to compete at that level, but yeah, the main goals is make it easy to hack on and integrate into other wallets. Remove that central point of failure of a coordinating server, and then from there iterate and make it better. I'm just not trying to achieve perfection on the first go around.
Jerry had some comments there. Could Cache Script contract help with adjusting the fees automatically, was one of the things he said.
Oh,
Down.
Well, that's interesting. Well, yeah. So in this first iteration, so what I'm going to do is take the work that I've done, add some documentation, put it up there, and then let everybody who funded the Flipstarter know that like I'm done. And hey, by the way, we're going to try and do a round 2 for improvements. And so in round 2, that's when I want to start to explore cash tokens. I'm already planning on adding SLP token support. I'm not expecting the community to fund that because there's just not a lot of interest in them. But we personally have interest in them. I would love to have the PSF token be more fungible by being able to go through a coin join. And same with Tether. They still have their USDT SLP token. It's still viable and functional. And it would be great to anonymize them. And one of the things that I like about the SLP Tether is that they have no control over to freeze them like they do with the ERC20 version of Tether. And so these SLP tokens are nice because once they leave Tether's, wallet, they have no control over those tokens. And so it's a really good candidate for actually having anonymized stable coins. And then in May, when Cash Tokens comes out, I'm excited to see what kind of tooling also comes out for that, and we can start to think about adapting that to this coin join process so that we can have anonymized cash tokens. Yeah, I think Jerry's putting some notes in the comment. Thanks for that, Jerry. That he just shared a link to cashscript.org. Jerry, just for reference, put these links in our Telegram channel because these links will disappear once the Zoom meeting's over, and only the people in the Zoom meeting can see these. So, but if you put them in the Telegram channel, then they'll stay there and everybody can see them. But yeah. So we'll see. We'll see where it goes. I'm pretty happy to actually, just be able to do the demo I just did. It's been a long road. There's a lot of things, and I still need to get that into the graphical user interface. So it's not just a command line thing. There we go. Thanks, Jerry. Well, with that, I'd like to hear more from you, Aaron, about the stuff you've been buying from Bitcoin Creations, if it's one thing or more than one thing. Oh, yeah, sorry, Jerry.
Oh,
he's got to register with the bot.
Oh, all right. Well, yeah. So I've been excited just with what Bitcoin Collab has been doing. Like they're another Midwest company. So they're down not too far from where I am. And it's just kind of fun to see what people are taking on as being important to them and then really turning it into something that can be they could actually make money with, and it can support the entire ecosystem, right? So that's why I'm loving part of that. I mean, so here's what I did. So far I've only bought one thing, and I'm excited about seeing what could be done. I mean, this is one of those weird. Jerry's like, yeah, he'll do that later. I understand that. This idea of like, that's fine that we have computers and stuff, but if they can't interact with the real world and don't help in real situations, it's like I remember when I had my first computer back during college, I didn't feel like it did anything until I could print, until I had a printer, right? Then it interacted with the real world. Yeah, you could do calculations and stuff, but it wasn't, it was less you could do on the internet at that point. So, this is one of those things where it goes, well, this is where Bitcoin Cash, and I don't know what their future is in other UTXO chains and or cash tokens and or SLP tokens either. But the idea of being able to take something and physically have it be somewhere, be able to take your wallet with Bitcoin Cash and buy something instantly without, again, permission. You just basically walk up to it. You want to buy something, you hit the button. And the other cool part is if there's something in that thing that somebody wants and they can't use their regular dollars, they have to get Bitcoin Cash or something. That's another thing going, oh, well, what is this? I'm going to find, or they're just going to get annoyed. I'm not sure which.
Well, I'm planning on doing that on my own island. I'm going to set up not technically a vending machine. It's just going to be a chest freezer with good stuff in it and a bunch of QR codes, but I'm only going to accept either Bitcoin Cash or like a stable coin or something. Like I won't accept fiat. I won't accept cash. And so it's going to be it's going to piss a lot of people off, but that's kind of the intent. It's like, well, you know what? I don't need to do business with you. This is the money that I am willing to accept, and you're going to have to find some.
So that's fun. I mean, I think these are the kind of things. Now, if you got a big freezer of things, it's really, you can't portion out, a big thing of beef into a little box and then have a scan and then it comes out. But so there's some limits to what you can do automation wise, but it totally makes sense to make this something easy and fun. So let me just bring up, if I may, share my screen real quick, what I'm looking at buying here, or what I did purchase, and I haven't actually got it yet, but I mean, it's such a fantastic technology that he's been making that I really want to kind of show what this is. So the idea here is that well, here's my first bit. I have this little, what do you call it? 3D printed candy machine, right? That I made, and you just spin the little thing, and it's got a Nutella jar on the top, and then you spin it, and then I don't know, any kind of candy you want comes out. I have M&Ms in there right now.
Okay, so you made this. I thought he made this.
This one I made, I was going out and just sort of looking at this thing. Okay, I want it to interact with the real world. So let me grab one thing real quick. So I bought this before. I don't know if you guys have seen the IOZetta. This is crypto power. So, and I don't remember the guy's name, but he sold these on Amazon, and basically it would create an address and you can send it to it, and it would turn the power on you could have a couple different ways. You could say if it's 5 cents, it'll stay on for 5 seconds. If it's 10 cents, it'll stay on for 10 seconds. They had some cool things. I've not used this for a while because I didn't have a specific use case, and I think some of the servers were shut down, but really cool, interesting things. So the idea then was, I mean, at one point I was like, okay, I want to make an experience where you walk in, if you're doing karaoke or something, and you could turn the light on, so if they're singing a song, you want the disco light to turn on, you pay the thing and it starts lighting up and people are like, oh, that's fun, and you can vote on things, that was this sort of experience that I wanted to create. But,
just for people who don't remember, there was, for a while, you could feed the animals. There were these webcams on a farm, and the dude you could feed these chickens and these sheep by sending a QR code, and it was a ton of fun. I think he had to shut it down because it was so popular and the animals were getting so fat.
Yeah, I remember, because you can actually see the food come out, right? You pay it and it goes bloop, and then you see the food come out. So you go, like,
animals would get all excited. They'd hear it coming.
So this is the point you're making there too is that, yes, it can also be a global thing, right? I was thinking locally, right, in the same room with people, the disco light turns on, there's you pick a song, you send it, and you get all this additional kind of cool functionality. But it's got to be pretty inexpensive if you're going to do more than one or two things. And so what I was looking at was, one, it's got to be faster. And so what Bitcoin Collab's been doing is making these really cool little big, I guess what I'm going to call them, it's like Bitcoin vending machine functionality circuit boards. And they're all already combined into one little thing that you can put into anything. And they've got a little screen on them. So it'll generate and it'll display and it'll activate. So I need to, for my case, I don't have all this stuff done yet, but I want to get a little stepper motor. So as soon as you pay X amount, the little thing spins and the candy comes out. I mean, this is, IOZetta dude actually made these before. So this isn't brand new. This isn't groundbreaking, but it is like moving it forward in technology and to something that's a company that can support. Now go back down to St. Kitts. Now I don't know what the heck's going on in St. Kitts after watching Sonny's channel kind of explode. Yeah. But with if you have, like you do on the island or down like St. Kitts, if you had a place where lots of people have this cash and they have an easy way to get in and out and a way to be able to spend it, it becomes something super fun and easy, and you just carry your phone with you. And someone can actually give you from, like you talked a moment ago, globally. Someone could just send the address to somebody and someone else can pay it on the other side of the world. So there's a lot of these things. So this is what I'm looking at doing. I don't really have a whole lot to show yet, but I'm excited about showing this and getting this working.
Yeah, I think this is what I was missing. So this is what Bitcoin Creation's making, and it's essentially a relay, right? So the screen displays a QR code, you pay it, and then that green header on the bottom, that turns on for a period of time and allows power to pass through it. And so that's what's going on, right?
Right. Yeah. It's a pretty simple, I mean, okay. I'm saying simple mechanism only from the relay side. The mechanism to make all this work and have it be small enough and have it do Wi-Fi and keep track. I mean, that's not simple at all. And
Yeah.
I mean, oddly enough, I did have some discussion with the Bitcoin Collab guy talking about how difficult it was to get hardware working.
Right.
Meaning
Hardware is hard.
It's hard. And the crazy part about it is if you do something like go to Fiverr and try to find somebody, the fact that you're paying in Bitcoin, or not even paying, you're just talking about Bitcoin, means that they think you're trying to bypass their system and pay them outside of it. So they constantly shut you down. Every time you put something out, they want to shut you down. So it's an additional problem that I wouldn't have thought made sense, but because Fiverr and other ones want the money to flow through them so they can continue to get the money, they'll block anything that even appears to be causing that problem.
Yeah, Upwork's the same thing. They explicitly have all over, like, do not pay your contractors in crypto. Contractors, do not let the employers pay you in crypto. They want everything to flow through their website, and they don't want to support crypto.
Are they
Right, so they
shipping
don't want to support
worldwide?
anything. What is it?
What's that?
Are they shipping worldwide? These boards?
They will be. Right now they're just getting the first ones done. I mean, I think they're getting receipt of the first official set I think next week. And what I was hoping to do too was to say, hey, we as a community of BCH supporters and of people that care about permissionless money, I want to make sure I'm there supporting them right away. Right. So he will ship. I don't know what the difficulty would be shipping to Tokyo or any other.
Yeah, if he
country
can't
right
do
now,
it, Stoyan, I'll do it. I see. This is why I wanted you to present on this, because I was confused. I was like, "Are you buying this 3D printed thing?" Turns out you made it. What you bought is the relay. I want to buy one of those relays, so I'm going to reach out. I'm going to buy at least one. Stoyan, if you want, I can. If he can't ship to Japan, I'll buy two and ship one to you.
Yeah, I'm interested in this. I have like maybe 10 different boards. We was talking with the guy about this before. So yeah, will be interesting to try it.
Yeah, I mean, on a personal level, I'm the I think the microcontroller he used is called ESP, and it's such a low level microcontroller. It's definitely less expensive, which is a good reason to use it if you're going to mass produce it. But I think I'd like to replace it with a Raspberry Pi or some more general purpose thing. But other than that, I mean, that one, just the choice of the microcontroller, who cares? It's not an important thing.
Yeah, I think
But
it's
the
different
idea
class.
of the screen and the battery, and have it as an integrated unit that just, you can pass power. It's very unopinionated as to what you're going to use this thing for. I think it's a wonderful idea.
Yeah, exactly. It doesn't care. You can then define what you see as being important and can create with it.
I remember from my talks with them, they went through a lot of hardware iterations, and trying to find what works and what's cheap enough that they can make
I
a profit
think
selling it.
Raspberry Pi is pretty expensive for these purposes because it's like full feature computer. But these guys, they just using like a single chip computers, like some kind of Arduino like stuff.
Right.
So it's like reducing the cost a lot. So yeah.
I mean, I think in bulk they can produce, I mean, those chips that they're using, they're super cheap. They're like somewhere between 5 cents and 25 cents per chip. But then you got to put them on the board, and that adds up.
Yeah. They're paying to integrate it with the board to make everything work, and so, but I think it's great. I've been watching, they've been working on this for a while, and now that they're at this point, and I commend them for just keeping going,
Perseverance. Yeah.
this whole time.
That's exactly it. And I mean, one thing he mentioned too is that as a sort of alpha user, there's going to be firmware updates, right? And so as a person who's doing it right now, don't expect everything's just going to be bam working. And there's going to be firmware updates. There's going to be things you're going to have to plug into it to make sure. So I that's one of the things that I'd say I don't know where it is yet or how much effort it's going to be able to go beyond and take it in different directions. But that's what their goal is, to make it easy to do so.
That's a good point. Yeah, if anybody's watching this and gets excited, like I not only am I going to buy the board, I'm going to buy the hardware I need to flash the ROM and reprogram it. I mean, I used to do this stuff in college, so I'm very familiar with that type of stuff. And it sounds
It's
like
very
Stoyan's got a lab
easy
for that.
It's very easy recently. You don't need flashing stuff because the recent Arduino boards, you just need to connect them to USB on your computer.
Nice.
So there's no more old flashing stuff like before.
Right.
Yeah. Hopefully.
I know when I worked at a large major corporation for a long time, and whenever they did hardware, it was always so difficult. And this is for a multi-billion-dollar company to actually keep going, and a lot of the projects would get going and then they would be abandoned within a year and a half because hardware is so difficult. So I commend the Bitcoin Collab people for continuing persevering through all of this and making a really interesting and fun product that's flexible and less expensive by far than stuff that's been out in the past.
Yeah, I like how he's I'm gonna step back from what I said before about using the Raspberry Pi, because he's really teed himself up for mass production. Like everything you can tell by his hardware choices, these are all parts that get significant discounts with high volumes. And so I like that. I hope that all this perseverance pays off and he's able to find a niche that can just mass produce the shit out of these things. It'd be awesome to see them all over the place.
He's also got some partnerships, and I'm not going to mention them because I don't know if he wants that done, but some big partnership that's come up recently that'll help with a lot of, I don't know if it's financing necessarily, but I mean, just the mind work that's involved with doing this and taking care of it and helping and moving it forward is massive.
Yeah.
It's, I see this as a positive, same way I see the SLP tokens as a positive, and that, there's been a lot of hype over a lot of different stuff. And it seems like over in the BCH side of things, the guys like you have been just working, making stuff. Now you have this token mixing or this cash mixing application, and you got something like this that makes it really easy for people to start using and adding that to vending machines. I remember this started with a vending machine idea. Like, I don't have any money for the washing machine. Why can't I just use Bitcoin Cash? Right. And like the idea was, oh, you could just retrofit at, vending machines, which there's a lot of people that own vending machines out there. And so that's a whole market in and of itself.
I think
there's no cash sitting in the vending machines.
Avalanche guys, they was doing something similar. I read some project. There's like ready modules. You just plug inside the vending machine and it start accepting like AVAX. I think some Bulgarian guys even was doing this.
That was the route I was planning on going, which is if you have an existing vending machine, most of them have a 9-pin port that allows you to accept credit card payments. And so that's what they're hacking, they're hacking into that port and they're simulating a credit card point of sale with a crypto type deal. And so I thought originally that's how Aaron was going to go about doing it, because I assumed that washing machines had the same port, but I like the more general purpose approach that he's taken of just a relay and you can pass power through it. And so that wouldn't work to retrofit a vending machine, but you could build a whole vending machine around it. That's right. Another thing, like the LN bits, that's the approach they've taken. They have this like 3-item vending machine that you can get and customize. And so it would work with like what Aaron's built, where it's just a relay on off type thing.
Awesome. I want to hear about the DeFi stuff that Stoyan was talking about.
Yeah, take it away, Stoyan. Tell us more about this Meson platform.
Can I share my screen?
I'm going to
Yeah,
mention one thing real quick. Like Thorchain has, they mentioned that Thorchain is another DeFi protocol that allows multi-chain thing. One of the things that they did recently is there's a new Maya one. So Thorchain has been forked. So they're allowing all of their code to be forked. So more people will be creating DeFi, but it won't be just Thorchain. It'll be Maya. It'll be focused toward Zcash. The idea is to bring in multiple. So I'm glad to see other. This is why I'm super excited about this. I don't think it's a fork of Thorchain. I think it's a different thing. But the idea that this is the beginning, this is where it starts. So I'm excited. It's about seeing Stoyans as well.
Well, yeah. I'm glad you brought that up, since we're talking about swapping stablecoins cross chain. Maya, it's interesting thing there, because Thorchain has now sort of achieved a level of mainstream adoption. They're really hesitant to integrate blockchains like Dash that are considered privacy coins that governments have like explicitly come out and said, like, we consider these bad, do not do these, or you're going to get on the wrong side of us.
Exactly.
So that's really the niche that Maya is filling. Is they're going to be the Thorchain for all of these coins that are a little too politically risky for Thorchain to integrate. So yeah, I'm great to see the market providing for the demand and supply that exists.
Yeah, I think what was interesting, I'm not trying to promote another like EVM stuff or something. This one I wanted to talk about is because it's very close to the talks that we have about conversion. First, it was only stable coins, like we before was talking. On the surface, it looks like usual, like swapping site, and you just choose the blockchain, and they have a lot of them, and you choose what coin you have, and it was very fast. It was like for less than a minute, and no fees at all. So you just pay the transactions. And when I look more closely, this one is not a different blockchain. This one is just implementation of the atomic swap. That was the idea from the Bitcoin era.
Yeah, I was struck by that as well, that these are hash time lock contracts, which is a really common way to do swaps in Bitcoin.
This Meson, I think the pronunciation is EVM, maybe,
but these work on EVM.
Yeah, its pronunciation is Meson. I think Meson. It's part of the atom. That's why atomic swaps. So, and the other interesting stuff is that if you look inside, the transaction starts offline. So this swap request is just a usual JSON data, and they're using something named relayer. Like you can see here how these transactions are going there, proposed for transaction. And I think this was a great use case for our pay-to-write database. You can use this instead of their relayer, because it will be the same. You just post this request. You're waiting for somebody to, on the other blockchain, to see, okay, I want to swap. And it's doing the swap automatically. So it's not a different blockchain, but it's more like a process between two blockchains, using a peer-to-peer like a database, which is our pay-to-write database.
Right.
So, and it's doing atomic swaps. So it's, I think, very interesting, and we can use it because it does not require to be exactly EVM. You just can have this relayer and other stuff with our stack, and just one side to be EVM, another one, it can be maybe with our current tools.
So, okay. Now I see where you're coming from.
Take a look, because it sounds interesting and it's working very well. The example demo, I tried it between several strange blockchains, and it was very pleasant experience. So yeah,
that's
maybe
awesome.
it will be
Is it
interesting.
still just mostly stable coins?
It will be only stable coins, I think.
Okay, yeah.
Because they mentioned in the beginning, if you read their documents, they mentioned about the main problems with the atomic swap, and one of them was that with time the rate can change, so it need to involve some balancing in the end. If in the beginning of the swap the two of the how to see the stuff that you are swapping, they change their price. But with stable coins, you don't need to care about this. It's just same coin, just on the
Right.
different blockchain.
Right.
And also it's addressing also another problems like these pool providers or something like this one. So they solve most of these problems. So you don't need to, because it's stable coins and you usually don't have the button, you don't need to mint. It will just get
Right.
you will lock the on the one side and unlock on the other side from some pool, and you don't need to mint and burn, which also was,
Right.
I think, nice.
Yeah, this would be a good model for building a bridge, say between the Tether SLP token and Tether on another EVM blockchain.
Because and the good stuff that it's completely open source. All of these they have GitHub repository where you can just get only the EVM side, see how this relayer.
Oh, okay.
Yeah, and this relayer.
Now I'm starting to see how your brain's working here, Stone. Because these aren't really specific to EVM at all. They're their own sort of thing that exists in a JSON document.
Just how to see something like a stack, like our stack. It's just a stack for going between the blockchains.
Yeah,
which was pretty nice, I think.
Huh. I'm gonna have to dig into this a little deeper. Now you really got my gears turning. Like,
yeah.
It should theoretically it shouldn't be that hard to adapt this to SLP tokens.
Yeah, it's
interesting thing about the idea of doing just stablecoin to stablecoin, because there's no conversion, right? It's like super simple. I mean, I think that was a brilliant thing. You know what? Let's make something that works great between, and we don't have to worry about conversion or costs or anything. So it's fun to see that, but then to expand.
And this relayer, they're using it now like a service, which is again great for our use case. Everybody can run this relayer, which will do the stuff about the offline to online.
And everything's written in JavaScript and TypeScript, huh?
Yeah, so I think it's pretty close to our way of thinking. That's why I wanted to show it, not just because I wanted to propose some new swapping service or something.
yeah. I gave this a cursory look, but now I need to dig in deeper. I see what you're saying. Their sort of design philosophy is very similar to ours.
That's why we was talking exactly about this. So
man, if we could tap into this with just the Tether SLP token, that would be great.
Yes. I will stop sharing, and maybe my my Zoom will crash again like last time. So be right back. Maybe
I can take control if it's easier. Okay, there we go. You're still here.
Oh, nice.
Well, that's awesome. Great info, you guys. I love these meetings. I love just all the cool stuff. Like, I think what I'm doing is cool, and then you guys share your stuff, and I'm like, whoa, that's really cool.
Join always blows my mind anyway. So whatever he's got.
Yeah. Okay. Well, does anybody have anything else they want to share before we wrap this up?
Aaron, maybe he's only one which didn't talk about his cool stuff. Maybe he's even cooler.
Well, he was talking about his point cloud calculations before we got on. That was pretty cool. But yeah, well, I think I'll wrap this up. I
Oh, I was
have a
muted.
meeting.
Sorry.
Oh, there you are.
I think I will develop a little bit more before I share anything concretely with everybody. But yeah, just been mapping stuff and messing around with the graphical database and getting to know that side of things. So
Yeah, I'm excited to. I'd love to have you give a demo of your graph. Is it GraphQL? Or using different
it's
graph?
Neo4j. GraphQL is the what I use to talk to the API back. Like GraphQL is kind of weird. It's like an API for APIs, but it allows you to just query specific things and not get back all the information. So like in your case where you're saying, I'd like to just see these areas within a certain zip code, you could query very specifically for that area and pull back that. And maybe you don't need all the information for anything, you know, or maybe there's just like 3 bits of information you need to bring back. That's all you bring back. And so it makes it really easy to bring that in, parse it out, and then put it into a front end application.
Yeah, the thing that I'm consistently struck with is how fast these graph-based databases are. I would expect them to not be as performant.
Oh, they're
but
incredibly fast.
Everybody raves about how fast they are. Yeah, and I'd like to understand like why that is, or why I even think they shouldn't be that performant.
It has to do. I guess I can just talk a second about this. I don't want to. It's a long tangent, so I don't want to. You know, we've gone a while, so I don't want to take up too much.
Yeah, let's do the 5-minute version.
Let me see what I can bring up. So. Yeah. I should basically I'll give you an example of yeah, here we can do this. I'm working on setting up things. A lot of when you're dealing with graph databases, a lot of it is set up. So here is a bunch of nodes I'm actually working on for a scheduling this section. And like when we come into here, we have days of the week, and then they're branching off to months and stuff like that. But each one of these things is a relationship. So like in a relational table database, you would have a foreign key, but you can't store any metadata on that foreign key. Whereas with relationships, I can not only name the relationship, but I can add properties to this. I can say, this is a property, whatever, and then I could say green, so that when I'm querying the database, I can look specifically for relationships that have the property green on it. And that's all that I want to look at. And so I can also look at, so when I come to the database and I say, I want to look up, say I want to look up the distance from one place to another. And I should have had this prepared. I'll have it for next time. And I can show the distance to different places. Like this is the desktop kind of browser thing here. And I was going through and changing stuff on the entertainer nodes, and we can come to the database and just quickly bring up, let's bring up cities, and we'll look at, we got about 25 cities on this graph. Let's expand that. And okay, so this is the city of Brooklyn in New York. And on this node, I've got all this data associated with it. And then each one of these is a relationship. And this relationship is to retirement homes that are in that city. And each one of these retirement homes has nodes. And then these blue and green ones are actually roads. And if we come down to this stuff, we can see that on this, let's pull this one out. There's actually other databases that you can look at that allow you to visualize this better. Okay, let's get this one. All right, so this relationship here, this route relationship, actually has stored on it an ID for the relationship, the distance in kilometers, and the distance in miles. So I can run functions on this that say, all right, I want you to route the shortest path, from one location to the other, and then give me back the distance in kilometers. And it does this in a matter of seconds. And this database right now has 631,151 nodes in it. And I can, let's say I want to pull up US routes. And this brought up US route 1. And this also has the data of, I can see that it's in Florida. And so this is all the connections in Florida. And then I can come to any one of these nodes and branch off and see, here's all the cities that are connected to it. So it's a real quick way to analyze and see the database. But you really have to start thinking about well, how am I going to connect the database? What's going to be a node and what's going to be a relationship?
Right.
But the big thing is I can query now through relationships. So instead of just saying, I need to match this to this table, this table, or look at this JSON document and look at the information stored in it, I can say, all right, start at this place. I'm in Omaha. I want to get to Chicago. And along the way, I want you to show me 3 cities along the path. And boom, it would show me the cities along the path. And there's other stuff that it's used for, like security, fraud detection, stuff like that. This is one of the ones. There's also like Tiger Graph and a few other ones, but they've got a lot of resources. And so I've been trying to understand them. They use Cipher query language, which is slightly different, but it's pretty easy to work with. And then you can actually import a CSV as a bunch of nodes, or you can, that APOC functionality I was talking about, they have a APOC JSON document load. So you can take JSON documents, say from a MongoDB, and you can load them in and then say, okay, I want these properties to be node properties or nodes, and I want this these objects to be properties on that node, and then I want this to be a node, and I want you to create a relationship between those 2 nodes that says this is now a relationship. And then you can work on creating stuff where you create and destroy those relationships. So like take your kind of Craigslist type of ad, you could say, all right, show me all the people within this distance that are on here. It finds them, pulls them back, and then say that you want to make a deal with them. You could establish a relationship between that person, and on that relationship could say they've made a proposed deal to sell X, Y, and Z, and it's on chain. And then you can reference that relationship from an app to pull back. So like you're not necessarily storing that on either one of the parties that have made the deal. You're actually storing that in a relationship between the parties, so that afterwards you could say, okay, a Boolean true or false, did the deal go through? So if somebody wanted to have a record of their dealings, they could just go to them and say, look at all my deal relationships. How many of them went through? How many didn't go through? Pull up the history of what I've done. And then would you go to their node, and then it would just look at all those relationships and say, here's all the relationships. Here's all the people you traded with. Boom.
Interesting. Yeah. It reminds me a lot of Tim Berners-Lee original conception of Web3, of the semantic web. How, it was mostly about relationships between data. And so this is an interesting incarnation of that original concept, and I can definitely see the application to local trade list if as it grows. I might need to consider one of these graphical databases.
It can be used even more commonly, not for the Craigslist itself. If you remember before, we was talking about creating a layer on top of the indexer. So all of the queries can be queried with GraphQL, which will increase, how easy you can create front-end software from the blockchain data. So it have a lot of application.
And so I can show one more thing you might be interested in here. Let me find the right, is this it? Yeah, I made it small enough so I can share. So this is Apollo Studio. And so what I've done is they have a NPM package called Introspector, which will look at your database and then it will pull out all the information. And so here is like queries, and we can go and we can say, I'm not going to run any mutations right now. I don't want to affect the database, but we can say, all right, I want you to show me nursing homes where they're, let's say their cities in, and then I can go like this, and this is the query up here. Here's the variables down here. And let's just say Portland. Now you spell Portland? Portland.
Yeah.
Okay. All right. And then so nursing homes where, and I want the name, and I think this is all caps. So let's just get the names. And oh, it just gave me a count of nursing homes.
Oh, okay.
Count of cities that, so, oh, that's because I have the city count there.
Okay.
Cities where nursing homes count. Oh, I see, I'm still learning.
Right. Yeah, I get the idea
GraphQL
now.
stuff, but you can go through here and mess around, and you can create your queries. So you can say like, I want to go back and I'm going to create a query, and I want to look at retirement homes where and I could look at them by beds and say, let's just return retirement homes by beds. And this just gave me all of the retirement homes in my database and each ones that have beds. And
Okay.
I could go through and say, I want to go through and say beds,
Yeah, and the name or
and
something.
say where beds, and let's say the number is 15. See, I entered that wrong. I think that might be a string.
Yeah, so this was my understanding of GraphQL. Is when it was first created, it was tightly coupled to MongoDB because that sort of query language in GraphQL like translated directly to a Mongo database query. And so that speed and flexibility, it was really coming from MongoDB, but that was years ago. I mean, I think now you can use it with other databases. You can use the same.
I literally have 43,000 retirement homes in this database, and it returned me the number, everyone that has 15 beds in 57 milliseconds.
Yeah.
And like I was saying earlier, when I plug this into my application, I had to change my React code because the REST APIs were too slow compared to running the GraphQL query. So it would go out, do the GraphQL query, come back, update state, and then re-render. And then because it didn't get I had like a Boolean cutoff switch, and because that didn't get rendered in the component that was with the REST API that would say, all right, stop querying, it kept querying and querying and querying. And it took me a bit to go, oh, this is going way faster than this other one. And so I need to put this cutoff switch on the one that's going really fast. So but yeah, this is really cool, because then I could take this and I can go inline variables, and now I can grab this and drop that in, and then you can write, so like this little $ is a GraphQL thing that says I want variables, and then you can just put those variables in there. And then hold on just a second, baby. And then you can add those variables as user inputs. So then the user could essentially query the database. So
very cool.
Anyways, yeah, sorry.
Yeah, great
little geek out stuff there, but yeah, it's really cool, really incredible. There are some other graphical databases out there like dgraph. I haven't checked them out. This one's built on Java. So if you actually know Java, you can actually write customized queries, and there's different libraries of people doing that sort of thing. So.
Wow. Wow. Okay, guys, well, let's wrap it up. It's been a great meeting. Thank you, everyone, for contributing to this. And we'll have another meeting in 2 weeks.
All right.